In the previous video, we discussed solving systems of equations using substitution, and this one will go over a new technique, which is combination. So let's go, before I start trashing the previous technique and talking ill of it, let's go over a great example of when the previous technique of substitution is really powerful. So let's say you have three equations. If we know y equals 4, we can plug that into here, so substitute that. So from here we could see the y is 4, x would have to be 2, and now we could plug in x is 2, so that's 2 times 2 is 4, minus 3 times 4 minus 12. So we have 4 minus 12, that's negative 8, plus what is going to get you 5, so that would have to be 13. So notice, using substitution, we were able to solve not just 2 but 3 systems of equations super quickly. So substitution is not something that's worse or better than this new method we'll go over. It's just a matter of what's appropriate for this problem, for the problem you're solving. All right, so in the last video we went over this problem. Let's go over how to do this using a new idea. So in this approach, what I mean by combination is we're not just combining the equations, we're technically combining multiples of the equations. So here's what we're going to do. These both look complicated because we have x's and y's and all these numbers. Let's say these weren't here, then this would look a lot simpler. So what we're going to try to do is make this look a little more like this. So if this were a 4, we could subtract the entire equations, and then 4x would get rid of that 4x, right? And then these would combine, and we would just be left with y's and numbers. So since this is not a 4, we're going to multiply both equations, in this case only this one, to make that a 4. So let's double this whole equation. So I'm going to refer to them as equations 1 and 2. So if we do 2 times equation 1, we're going to get 4x minus 6y equals 10. Now we've achieved our 4, and the order doesn't even matter. We're going to subtract this equation from this equation, or the other way around. All right, so I'm going to put a minus. Now, important, don't just put the minus, put these parentheses. Otherwise, you're going to forget to negate everything else. So that's gone. 5y minus a minus, so that's plus, so that's 11y. And that's 7 minus 10, that's negative 3. And here, we've already gotten that negative 3/11ths from the previous video in a much easier way. Now, at this point, using substitution, you could plug this back in to either of these and find your x, which should work out to the same thing no matter which one you plug it into. However, that's the substitution technique. We can do this again, but this time instead of eliminating our x, we'll make sure to eliminate the y to get x directly. So let's see what we're going to do. We're looking for the least common multiple of 3 and 5, so that will be 15. So we're going to take 5 times this equation and 3 times this equation. So we're going to 5 times equation 1, and we're going to do 3 times equation 2. All right, so what do we get here? We multiply everything by 5. Now multiply this whole thing by 3. All right, notice now we have 15s. Now depending on whether the signs are minuses or pluses, you'll want to add or subtract the equations. In this case, they were both positive 4x's, which is why we subtracted. Here they're opposites, so we're going to add them. All right, so that's going to be 22x. These are conveniently gone, which is why we've done this in the first place, and that's 46. So x will be 46 over 22, which will simplify to 23 over 11. Divide them both by 2. All right. Now, again, the numbers are ugly, but I would argue this is a easier way to get these answers than through substitution, because there's less work, there's less dealing with fractions, so there's less room for error. So that's sort of how to do this complicated problem. You pick which variable you want to eliminate. So let's say in this case we first wanted to do x, so we made these the same number. We made, if that was a 4, we turned that into a 4. Here we don't want to turn this into a 5 because we have to multiply this by 5/3, and fractional numbers are, the whole point is to avoid complicated stuff. So we're going to scale both of these to their LCM, or least common multiple, of 15. So that's the idea. Depending on what you want to find, you'll scale them both up to add or subtract and eliminate that variable. So that's the essence of combination. Now let's go to a problem such as this. So let's say you have x plus y is 4, then you have x minus y is 7. All right. Now, it's important to know when should you use combination and when you should use substitution. Let's try this using substitution. So we'll use this to create our substitution. We're going to move this y over and plug this into here. So we have 7 plus y, that's our x now from here, plus y equals 4. So we have 2y plus 7 equals 4. We're just solving this, and so y is going to be, we move the 7, that's -3, divided by 2, -3 over 2. It wasn't too bad, but now let's see if we can do this faster using, well, okay, so that's our y, and our x, we will just plug this back in here. So 7 minus 3 over 2, which is -1.5, so x would be 5.5. It was all right. Now let's see if combination is better for this one. So we're going to add the equations because they're already all 1 and 1, 1 and -1. Ignore the signs, but they're all basically the same coefficients, the same numbers. So if we add these equations, we get 2x, these are gone, is 11. So x is 11 over 2, which is the same 5.5 we just got. And if we subtract them, the x's will cancel, and we'll get everything is negated here. So visualize the minus distributing to everything. So that means these are gone, and we have y minus -y. So we have 2y equals 4 minus 7, which is -3, -3 over 2. So I would argue that combination is easier and better for this setup. However, substitution wasn't super bad for this one. It wasn't as bad as it was for our original problem here. So use your judgment. When you see a problem, before you start solving it, ask yourself, do I want to use substitution, combination, or maybe something else entirely? But most of these you'll solve using one of the two. In general, to keep it straight, if you see really ugly numbers like this, something really crazy, this doesn't look very simple, so for these complicated ones, you're going to go with combination. If it looks pretty simple like this, and you already have the substitution, use substitution. If you have something that's almost a substitution, you can just move one of them around. It doesn't matter too much. Combination, I would give it a slight edge for these. Still use combination, but here substitution is only a little bad. But here substitution would be a really bad choice. All right, I'll see you guys in the next video.